Bismillah ar-Rahman ar-Rahim. Well, students, today, by the grace of God, we have come to the end of the chapter, and now we have to start the exercise. The first portion concerns the multiple choice questions. The first question is, which of the following quantity is not changed during refraction of light? It has given four options: direction, speed, frequency, and wavelength. Please remember that the frequency of a wave does not change because it depends upon only the source. The source that generates the frequency has to alter to change the frequency. So the only quantity that is not changed during reflection is frequency. A converging mirror with a 20 centimeter with a radius of 20 centimeter creates a real image of 30 centimeters from mirror. What is the object distance? Use the formula 1 over f is equal to 1 over p plus 1 over q, and you will arrive and also use the proper sign conventions. The answer is minus 15 centimeters. Question number 3. An object is placed at center of curvature of a concave mirror. The image produced by the mirror is located at the center of curvature. Question number 4. An object is 14 centimeters in front of a convex mirror. The image is 5.8 centimeters behind the mirror. What is the focal length of the mirror? Use the formula 1 over f is equal to 1 over p plus 1 over q, where f is the focal length of the convex lens, p is the distance of the object from the lens, and q is the distance of the image from the lens, with of course proper sign conventions. The answer is 9.9 centimeters C. Question number 5. The index of refraction depends upon the focal length, the speed of light, the image distance, and the object distance. Always remember that the index of refraction depends upon the speed of light. You have read the formula on page number 43. Refractive index is equal to speed of light in air or vacuum to the speed of light in that medium through which it is being measured. So n is equal to c over v. So remember, speed of light always is in the refraction always depends upon the speed of light. The sixth question is, which type of image is formed by a convex lens on a screen? By a convex lens on the screen. When somebody asks you on the screen, the only image that comes on the screen is the inverted and real one. A real image can come on the screen, and a real image is always inverted. Question number 7. Which type of image is produced by converging lens of a human eye? If it views distant object, it will see a real, inverted, and diminished image, part B. Question number 8. Image formed by a camera is alpha. Answer is alpha, real, inverted, and diminished. Question number 9. If a ray of light in glass is incident on an air surface at an angle greater than the critical angle, the ray will, the options are 4. Option B is correct, reflect only. Question number 10. The critical angle for a beam of light passing from water into air is 48.8 degrees. This means that all light rays with an angle of incidence greater than this angle will be totally reflected. Option B. Now we come on to the review questions. And most of the answers are given in the test book, and you have to go through the test book and read that topic concerning the question. The first question is, what do you understand by reflection of light? Draw a diagram to illustrate reflection at a plane surface. Question number 1. See the test book and find out what is reflection of light and draw a diagram to illustrate reflection at a plane surface. Question number 2. Describe the following terms used in reflection: normal, angle of incidence, angle of refraction. See the textbook to answer these questions. State laws of reflection. Describe how they can be verified graphically. You have to again go to the textbook. It's on page number 37. Question number 4. Define refraction of light. Describe the passage of light through parallel-sided transparent material. Please look up in the textbook on page number 42. Question number 5. Define the following terms used in refraction. Angle of incidence, angle of refraction. Question number 12.5. Again, the answer lies in the textbook and see that. I want you to go through it so that you learn it by heart. Question number 6. What is meant by refractive index of a material? How would you determine the refractive index of a rectangular glass slab? Again, page number 43 has given the answer. Question number 12.7. State the laws of refraction of light and show how they may be verified using rectangular glass slab and pins. Please see page 42. Question number 12.8. What is meant by the term total internal reflection? Please again look at the textbook on page number 44. State the conditions for total internal reflection. 12.9. Condition. There are only two conditions. One, the first condition is that rays should go from a denser medium to a rarer medium. When the ray of light goes from dense to rare and the angle of incidence is greater than the critical angle, then total internal reflection takes place. Remember, these are the two conditions of total internal reflection. One, ray should go from a denser medium to a rarer medium. Two, angle of incidence should be greater than the critical angle. Question number 12.10. What is critical angle? Derive a relationship between the critical angle and the refractive index of a substance. See, please see page 42. What are optical fibers? Describe how total internal reflection is used in light propagating through optical fibers. Please see page number 45. Question number 12.12. Define the following terms applied to lens principal axis, optical center, focal length. Please see page 48. What is meant by principal focus of a convex lens, concave lens? Again, the answer is there in the textbook on page number figure 12.20 and 12.21. Describe how light is refracted through convex lens. Please see figure 12.23. With the help of ray diagram, this one is question number 12.15. With the help of a ray diagram, how you can show the use of thin converging lens as a magnifying glass. Please see page 55 and 56. Now the next question is 12.16. A coin is placed at focal point of a converging lens. Is an image formed and of what nature? No image is formed when it is placed at when the object is at the focal point of a converging lens. And see figure 12.25 in your textbook, because the rays become parallel after passing through the principal focus. What is the difference between real and virtual images? Now this is question number 12.17. A real image is always formed by concave mirror and a virtual is formed by a convex or concave. A real image is always inverted and virtual image is always erect. A real image, is formed at the principal focus of real object. It is formed at the virtual principal focus. Positive sign convention is used for real images. Negative sign convention is used for virtual images. And then real image is always in front of mirror and the virtual image is behind the mirror. The focal length is taken as positive for real images and the focal length is taken negative for virtual images. Please understand these things very thoroughly and try to get the concept of it. The next question is 12.18. How does a converging lens form a virtual image of real object? 12.18. Please see figure 12.24 and 25. How does diverging lens can form? This is also on the figure 12.25 and 24. Question 12.19. Define power of a lens and its units. Please see page 49. Describe the passage of light through a glass prism and measure the angle of deviation. Please see page 46 and 47. 12.21 says define the terms resolving power, magnifying power. For this you have to see page 55 and 56. 12.22 says draw the ray diagrams of simple microscope, compound microscope and refracting telescope. Please see the figures 12.30 and 12.31, 32. And for refracting 12.34. So the figures are for simple 12.30, figure 12.32 and refracting 12.34. Mention the magnifying powers of the following optical instrument: simple microscope, compound microscope, refracting microscope. Please see for page 55, page 57, page 58 for the answer. 12.24. Draw ray diagrams to show the formation of images in the normal human eye. For this you have to see the figure 12.37. 12.24, see figure 12.37. Okay, and what is meant by the terms nearsightedness and farsightedness? How can the defects be corrected? Please see page 60, it's given on the book. And the next thing that we have to do is about the conceptual questions. Excuse me for some time. Bismillah, well gentlemen, after covering the portion of review questions, now we come on to the conceptual questions. Open up your books on this, on page number 66 and keep following me one by one. The first conceptual question is, a man raises his left hand in a plane mirror. यानी plane mirror के सामने से जो आम शीशा आप घर में देखते हैं बाल बनाने के लिए etc. जो वॉशरूम में लगे होते हैं, that is a plane mirror. So a man raises his left hand in front of a plane mirror and the image facing him is raising his right hand. But what you see in the image is the right hand that the man raises. Now explain how it happens. Suppose you stand in front of a mirror and you raise your left hand, but the mirror shows you that the right hand is being raised. It is because the light rays after reflection, they cause a laterally inverted image. The rays from a plane mirror always form a laterally inverted image. Therefore, the left of yours is the right in the image. The next question is 12.2. In your own words, explain why light waves are refracted at boundary between two materials. Now this says, why does the phenomena of refraction take place at the boundary of two materials? This is due to change of speed of light while traveling from one medium to another, also because the change of refractive indices of material. It takes place at the boundary because change of speed of light. It is just like when you are driving and you go from a hard road onto a desert road. At the boundary of that, because of the speed of the vehicle, you will see a change. So this is due to a change. Refraction takes place due to a change. Okay, quite 12.3. Explain why a fish underwater appears to be a different depth below the surface than it actually is. Does it appear deeper or shallower? It is due to the phenomenon 12.3. It is due to the phenomena of apparent depth, because when you see light rays are refracted and you see not the actual depth of the water but an apparent depth because of the refraction phenomena. Because of apparent depth, as a virtual image is formed at I above O. This is the actual depth of the pond or lake and because of refraction of light you see the image here. So this is why you see that the apparent depth is above the actual depth. So explain why a fish underwater appears to be a different depth. This is the reason why it appears a different depth. And the image over here is formed above, and actual depth is at this point. So this is the real depth and this is the apparent depth. 12.4. Why or why not concave mirrors are suitable for makeup? Concave mirrors are suitable because they act as magnifying mirrors. Concave mirrors are useful for makeup because they act as magnifying mirrors. When person is between the principal focus and pole, when the person is standing between the principal focus and the pole of the mirror, then of course you get a magnified image and hence you can see things which are needed to be seen. 12.5. Why is the driver's side mirrors in many cars convex rather than plane or concave? It is convex because it gives an erect and small image. What you need is, in the mirror you want to have a wide scope, wide view of objects behind you, and you want to see them erect. So that is why it is used. 12.6. When an optician's testing room is small, he uses a mirror to help him test the eyesight of his patients. Explain why. Because to increase distance of the alphabets from the patient, there you place a mirror behind and the distance is double now to the appropriate distance that you want. So that is why if the room is small, you put a plane mirror and the reflection takes place twice. The distance becomes doubles, and that is why. 12.7. How does the thickness of lens affect its focal length? Thickness, I told you, focal length is inversely proportional to thickness. The more the thickness is, the less is the focal length. 12.8. Under what conditions will a converging lens form a virtual image? When object is placed between F and the optical center, image will be rect, magnified and virtual. 12.9. Under what conditions will a converging lens form a real image that is of the same size as the object? When the object is 2F, you get the real image, inverted image and the same size mirrors. 12.10. Why do we use refracting telescope with large objective lens of large focal length? Because objective lens, large focal length to gather more light from weak sources. 2. To make them more visible. 3. To increase the resolving power of the telescope. So now with that we move on to the numerical problems now. And please go through these conceptual questions, make notes of them with clear diagrams and headings. Thank you.